as before, like we were saying, we're going to go ahead and perform those change of variable operations for this fourth order differential equation. So like we did in the last example, we'll need to define some new functions, and this time we'll need 4 new functions. So the first function is going to be x1 is going to equal y. All right. So this is going to imply, if we were to take the derivative of both sides, just as before, it's going to be x prime of 1, okay, is going to equal y prime, okay, and this is going to equal x2, right? So guess what we have to let x2 equal inherently? We'll have to let x2 equal y prime, okay? So this is going to imply, and you'll probably begin to spot a pattern here, it's going to be x prime 2, right? And the first derivative of the, the derivative of the first derivative is the second derivative. So now we have this defined, and we're going to let this second derivative be x3. So x3 then equals y double prime. So this is going to imply, when you take the derivative of x3, that will have to be the third derivative. And we're going to let this be x4. Okay? So now that we have x4, okay, and this equals y triple prime, if we were to take the derivative of this, something special happens. We get x prime 4, okay, and that's going to equal y4. And bingo, this is exactly what we want. So like before in the last example, you want to isolate the y to the 4 term, which would be this term right here. Isolate this term by moving all the other terms to the other side, and then substitute your change of variable into that equation to finish this off. Okay, so let's do that. If you do it correctly, you'll find that y to the 4, okay, is going to equal negative 8y, all right, plus sine of t, okay, times y prime minus 3y double prime, okay, plus t squared. All right. So this implies that y to the 4th, okay, which equals, by the way, x prime 4, okay, will be set equal to negative 8x1. That's what x1 is. It's y. Okay, plus sine of t x2, right? And then it's minus 3x3 plus t squared. Okay, so there it is. That is the expression that we need for x prime 4. Now it's just a matter of writing out the system correctly along with the true initial conditions. Okay, so the way we do that, like before, we have our first derivative, right? We want to write a system of first order linear differential equations, which is why we use the first derivatives in all these cases. So x prime of 1 equals x2, okay? and x prime of 2 was equal to x3. X prime 3 was set equal to x4. Okay, and then last but not least, x prime 4 was equal to the term we just found, which is the negative 8x1 plus sine of t x2 minus 3x3, that more of a 3, plus t squared. So now all we need now are the initial conditions, which are taken directly from up here, except now we just need to substitute instead of y, that's going to be x1 instead of y prime, that's going to be x2, and so on. So this means we have x1 of 0 equals 1, okay? And then next we have x2 of 0 equals 2, okay? Then we have x3 of 0 equals 3. And then last but not least, x4 of 0 equals 4. And that completes this problem. And you can see how you would repeat this process every single time. Additionally, and here's the good news, no matter how big the system is, you can always apply a change of variable process to that equation and write out an entire system of first order linear differential equations that we can then later solve. So that's the great news. So I'll put a big check mark next to this process because I think this is super cool. And you'll be doing this again and again as well, professionally as well. This is a very useful technique that you'll use again and again. All right. So next up, just a nice little teaser before we move into the next section in the video, in our next video. We then need to be able to convert systems to what's called matrix form, right? So we want to be able to move from differential equations to matrices as well. So in our next example that we'll cover in the following video, the problem statement is convert the following system to matrix form. Okay, and the system is going to be x prime 1 equals 4x1, okay, plus 7x2, all right, and x prime 2 equals minus 2x1 minus 5x2. All right. In the next video, I'll show you how to perform this operation. See you soon.